Good day, friends. This morning we got this question on the way. Want to have a look at it. We are going to solve non-standard exponential equation. Our equation given, as you can see, is very interesting. The equation itself is not the standard one. So let's have a look at it. Okay, so we are solving this equation, non-standard equation. Let's say 2x is equals to 3x over 2 plus 1. That's the question we have. 2 raised to the power x. Okay. 2 raised to the power x. 2 raised to the power x is equal to 2x over 2. Different bases. That is conflicting, as you can see. So different bases. So you see, different bases. Different bases. That is conflicting. Okay. So what do we do? Let's have a look at it. Let's divide both sides by 2 raised to the power x. So say let divide both sides by 2 raised to the power x, and let's see what is possible. Okay, but we have to be there's a caution over here. We have to be cautious. So if you look at it very well, so we have 2 raised to the power x is equals to, we can write this one as root 3, okay, x plus 1. This can be expressed in this way. So this can be expressed in this way. Have you seen it? So when we do it in this form, it makes the equation very easier. As you can see over here, we have decided to make it the square root of 3 all raised to the power x, because the exponent of 3, which is half, when you multiply by this x, we have the same equation. As you can see, this is the same as this. Simply, it's very, very simple. So now we are going to divide both sides by 2 raised to the power x. So 2 raised to the power x is equals to square root of 3 raised to the power x plus 1. So we divide here by square root of x, and here by square root of x, and here by square root of x. If you look at it very carefully, you will see that this equation, we can break it down totally. Over here, we can say 2 raised to the power x, this will give us 1, and here, since we have exponent x here and exponent x here on both sides, we can say that we factorize. So this will become root 3 over 2 into bracket x plus 1 over 2 raised to the power x. As you can see, what does it come into your mind? We can further also write this one as 1 equals to root 3 over 2 all raised to the power x plus 1 over 2 raised to the power x. You see straight on, when you look at something like that, what comes into mind? You can say that this conforms to Pythagoras theorem. You see, this conforms to Pythagoras theorem, because if I draw my triangle, let's say this, then I have here to be maybe 30, and here to be root 3, and there's 2 and 1. You see that here being a 60, you see this one conforms to Pythagoras theorem. Okay, but let's see how best we can do this. Now, when we square, let arbitrarily square both sides of the equation and see. So when we square, okay, when we square both sides, again, you see, so we're going to take root 3 over 2 into bracket squared plus half squared. You see, we are going to get root 3 times root 3 over 2 times 2 plus half times half. So you will see that at the end of the day, we are going to get root 3 over 4, root 3 over 4, 3 over 4, we're going to get 3 over 4 plus 1 over 4. Yeah, which is eventually equals to 1. So you see that then we can see, then we can see x equals to 2 is a solution. Possibly. But we have to prove it further. So I would say note, there are no more solutions. There are no more solutions. Now we see the reason why. Or else x is equal to 2 is a solution. It's a solution. So since square ran both sides of equation yields the value of 1, which is exactly what we have on the right side. You see, okay, somebody will ask the question, what about if x is greater than 2 or x is less than or equals to 2? Okay, so x can be greater than 2. There are 2 ways actually. So I would say there are 2 ways here. Let's look at them both. See, so I'll write it down for you to remember. So let's look at both cases. Okay, if x is greater than 2, okay, then when root 3 over 2, then root 3 over 2, we know that okay, root 3 over 2 is also less than 1. You see that when we square both root 3 over 2, the value will be less than 1. And and have also less than 1. But when we decide to raise them to the powers, okay, we want to raise them to powers which which are greater than 2, which are greater than 2. We get values. Let me write all this down for you to remember. We get values. We are going to get values smaller and smaller, smaller and smaller. Have you seen it? When we raise it, when we raise 1 over 2 and root 3 over 2, you see, we are going to get values which are smaller and smaller as x approaches the infinity. Well, I know I'm writing so much text over here, but guys, it's very important for us to understand that if we raise the value of x, with the more values we raise, you see that our equation will be like that. Now, let's look at it mathematically. So, as our equation was given, root 3 over 2 exponent x plus half raised to the power x, which is equal to 1. When, look at it, when x is equal to even 1,000, okay, just look at how what it's going to be. It's going to be root 3 over 2 all raised to the power 1,000 plus half raised to the power 1,000. You see, you will see that this value becomes very tiny. So we say as x approach infinity, okay, the variable are getting closer to 0. You see, that variable are getting closer to 0. Isn't that interesting? They are getting smaller and smaller. It implies, okay, you see, today I'm trying to explain it in the easiest way for everybody to get it. So this expression is going to get less. Imply this expression above is going to get is going to be less than 3 over 4. Now, let's look at it from this perspective. If we have root 3 over 2 raised to the power x less than 3 over 4 and half raised to the power x less than 1 over 4, if you add them together, that's if you add the expression together, let's see, if we have the expression together, the result or the resultant will be less than 1. You know that. Now let's look at it this way. Even when x is greater than 2, okay, yeah, less than 1. When x greater than 2, so our root 3 over 2 raised to the power x is also less than 3 over 4 plus 1 over half root x less than or equals to 4. 1/4. Let's say less than 1/4. You see, when we add this together, so this addition, so as I put plus over here, you see that, so anything greater than 2, have you see? So anything greater than 2 will not work for us. Because even when it's the summation of the two, we are going to get our equation to be less than now. Well, now let's see. No, so that is when x is greater than 2. When we add this and that, this is what we get. Now let's look at the case 2. Case 2 is very interesting. If we take the same equation, root 3 over 2 raised to the power x, which is even greater than 4, okay, and which is also greater than 1/4. Let's see what we get. When we sum it together, you see, when we sum this together, what are we going to get? You see, we are going to get our root 3 over 2, okay, exponent x, plus half that, greater than 1. Well, meaning that x less than 2 is no solution. So it means, meaning when x is less than or equal to 2, there are no solution. No solution as well. Now let's look at it. Let's look at it from analytical geometry. Okay, so with analytical, let me write that this analytical geometry perspective. Analytical geometry perspective. Let's see, that is case 3. Okay, in analytical geometry perspective, okay, we have, it says that we have root 3 over 2 raised to the power x plus half raised to the power x, which is equals to 1, for instance. You see this, we force the equation to be equals to 1. So let's do this, we force, okay, the equation into let's say we force the equation to be equals to 1. We force our equation to be equals to 1. So we say we force the equation, okay, to be equals to 1. For the equation to be equal to 1. Now, but x is equals to, is possible solution as we saw earlier, but x is equals to 2 is possible solution. X equals to is possible solution. Okay, let the expression to be equals to 1 as we saw it. Okay, so we'll force it to be equals to 1. So let's call this one maybe the function of fx to be equals to root 3 over 2 raised to the power x, as we are forcing it, plus half into bracket x. Since we know that both root 3 over 2 and that of half are both less than 1, Okay, so let me state it. Since we know that both root 3 over 2 and half, okay, are both less than 1. The graph, as you can see, the graph of both are going to be decreasing. Okay, the graph of both are going to be decreasing exponentially. So if that is the case, the function the function become the function f of x become a decreasing function. The function f of x, let me see, the function f of x, I think that will do. So the function of f(x), becomes a decreasing function, becomes a decreasing. You see, today we are speaking much with English. Okay, becomes a decreasing function, and f of x equals to 1. It's a horizontal line. It's a horizontal line, linear, meaning, hence, is going to intersect at so hence there is going there's going to be an intersection at 1 and only 1 point. You see, there's going to be an intersection at 1 and only 1 point. Let's see how it looks like. Our function now is equals to what? Root 3 over 2 raised to the power s plus half raised to the power x. Okay, from this equation, you see, we also know that the actual equation f of x will be equals to what? 1, because of the value of 1 we saw earlier. Okay, now let's try and draw this curve, this line. Let's see, if we have this, let me use it nice, let me draw it nicely. Okay, now let's look at it. Let's look at it now. If I have this, draw this line very carefully. Beautiful. So if I have this, and this one go up a bit. Okay. If I have this and that, and this is the y-axis, as you can see, this, for instance, when we draw such a thing over here, our equation is going to be like this. Okay, that is the function f of x. Then f of x equals to this. So this whole equation is the function f of x equals to what? Equals to root 3 over 2 s plus half. Okay, then equation of a line for this one was, since we have f of x to be equals to 1, this would be a straight line. Okay, so this f of x equals to what? To 1. You see that there's only one point here. That if even the line passes through, f of x goes to 1, for instance. Okay, this one will be a value of 2. Okay, even if f of x passes through the point 1 here, like that, okay, this one is like this. Okay, where x is equals to 1 here, we see that the value of what 1 is not the real value. So you see that we can see there's only one intersection. Yeah, here. So there's only one intersection over here. So I can say boldly the intersection point only. Okay, there is only one. So as you can see, one intersection point only, and that is the value of x equals to 2, and this is the only solution ever for the equation. Friends, I know today we have spoken a lot of English in this particular question, because the reason is we have to really break it down for everybody to understand it. You understand? Because if you look at it, the whole equation is such that we have to look at it from various possibility when it comes to analytical mathematics. This is more analytical, because as we saw earlier, we saw that this equation can be expressed in this way, as you can see over here. When all what we did is changing the square root sign. Over here, the 3 over here, we have a half in it. So half being in it, okay, with them, that makes this equation root 3 raised to the power x. So we divided both sides of this equation, okay, by 2 raised to the power x, such that the x and such that x is not equal to 0. Have you seen it? So we say that such that this 2 raised to the power x shouldn't be equal to 0. Okay, else it doesn't make it possible. So from that, we see that this one conforms to Pythagoras theorem, because what does the Pythagoras theorem say? It says the square of the hypotenuse, okay, is equal to the square of the opposite plus that of the adjacent. And if you look at the equation here, you see that it's similar. So by squaring both sides of the equation, we realize that both will give us 1. Yeah, either 3 over 4 plus 1 over 4 will give us 1. So that we can say that if that is a situation, then the value of x is a possible value. Then we look at it from this perspective and say there are no more solutions, or else x goes to 2 is a solution, since squaring both sides of the equation yields the value of 1. Then we say, but if x is greater than 2 or less or equal to 2, then we look at the situation where x is greater than 2. So there are 2 ways here. Let's look at both sides. Was x greater than 2, then root 3 over 2 we know that root 3 over 2 is also less than 1. Consequently, half is also less than 1. Okay? But when we raise the powers to 2, we get values smaller and smaller. You see that the x value approaches infinity as we raise the value. That's why I set a scenario here. I say if we raise the value of x to 1000, then x value approaches infinity. So the variables are getting closer to 0. They are getting smaller and smaller. It implies the expression is going to be less than 3 over 4. So when we took this and that, okay, and we add them, even when they were in the less condition, when we add them, you see our x value, okay, was greater than 2. For instance, so anything greater than value of 2 will not work. And we look at this case again. You see, even one with square root of 2 over x is greater than 3 over 4, and that is also greater than 4. Okay? Then this equation also, we realize when x is less than or equal to 2, we have no solution. So we decided to look at it from analytical geometry. Okay. In analytical geometry, for instance, the whole expression, we coerce the expression to be equal to 1. So we forced an equation to be equal to 1. But x equals to 2 is the possible solution. So we decided to make f of x to be equal to the whole expression. And we also came out with the same analytical understanding. Then after we force everything together, as you can see, drawing our line, the curve over here, gives us a vivid explanation, the reason why x is equal to 2 is the only possible solution. The broken line I've drawn is just to explain for us to realize that even when x, the line is increasing of value, okay, then our equation is still hold that x is equal to 2 is the only possible solution for the equation. Friends, I think this is very easy to understand, That's why today we have spoken a lot of English in our mathematics. Yeah? Well, that's how we come to an end. My friends, take the bold step and go through it step by step and try to digest it. Okay? You realize that it's all analytical, and we are able to break it down to a extent that, even someone who doesn't understand maths can go through the steps and understand it. Well, friends, that's where we end. Please, as you know, I'll urge on to subscribe and also tell a friend that this thing is going on over here. And once again, also you can click on the bell so you'll be the first person to have the solution at your fingertips. Have a lovely day. Till we meet again. Bye.